Probably anyone who's ever had cold hands has, on some occasion, tried to warm their hands by rubbing them together. In this situation, you're using friction to your advantage. Friction is a force that exists between two surfaces that are in contact, and it depends really on two things. Oh, I'm sorry. Friction is also a force that opposes the relative motion of those two materials that are in contact. Friction really depends on two things. How hard those two surfaces that are in contact are being pushed together. And we know that 'cause intuitively, if you just push harder, your hands get warmer quicker because there's more energy being turned into heat, there's more friction. We call this the normal force, and I'll get to that in a minute. The other thing is the nature of the surfaces in contact. Like, what is it about skin on skin, or in the case of your car tires, rubber on concrete, that leads to either a little or a lot of friction? The nature of the two surfaces that are in contact and how much friction there is between them is measured by something we call the coefficient of friction. Let me see if I can change the nature of my hands and create less friction. Maybe I'll use some soap and water. Hey, I have a bucket of water and a bar of soap here. So if I moisten my hands a little bit and put a little soap on them, there's almost no friction. Well, there's some friction, but there's a lot less than there was a minute ago when my hands weren't soapy and wet. So something about the soap lowered the amount of friction. We would say it lowered the coefficient of friction between these two surfaces in contact. A minute ago, I said I'd elaborate a little bit on why we call this the normal force. Let's have a look. I have 1 kilogram here, and for no reason other than to show you for something that I'm going to show you in a little bit. I want to show you that I have what's called a Newton scale. This actually weighs things in newtons. Now, if this is 1 kilogram and we're on Earth, what would it weigh? W, the weight, equals mg. And we know g is 9.8. So 1 kilogram ought to weigh about 10 newtons, 9.8. Now, if I put this kilogram on the table, does the table do anything? Well, it's holding up the kilogram, so it's doing something. How much is it pushing up on the kilogram? That's the normal force. The table itself has to exert a force, or else the kilogram would be accelerating toward the center of the Earth and falling at a rate with an acceleration of 9.8. The table pushes up with a force equal to the weight, and the reason we call it the normal force is it acts at a right angle. This angle between the force the table exerts and the table itself is always a 90-degree angle. Why 90? Well, think about it. All a surface can do is push away from itself. It only can push at a 90-degree angle. If I were to bump into a wall as I'm walking, I just bump into a wall, it pushes me away from itself at a 90-degree angle relative to the surface.